so good morning, everybody, and welcome to another exciting Exploring by the Seat of Your Pants broadcast. My name is Jesse, and I know we've got a lot of my favorite classes and groups in today, but if you are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. And welcome in. We are like in our home stretch here. We're on like the final 5 or 6 broadcasts of an epic school year with over 500 programs that we've done with scientists and explorers around the world. All of them are on our YouTube channel, so you can check out absolutely anything you want to there anytime. We just wrapped up our Oceans Week last week. Oceans Day is June 8th every single year, and to commemorate that, we did 21 programs with amazing ocean advocates around the globe. So do check out that YouTube channel, one of my favorite weeks we've ever done as an organization. Today, I'm so excited to welcome back the amazing folks at the Schmidt Ocean Institute. We have been doing programs with them for like 5 years. I think we've done like 30 broadcasts with them, so they're up there in the upper echelon of the coolest partners that we've ever partnered with around the globe. And without further ado, I'm going to welcome in Hannah Nolan to explain a little bit about what the Schmidt Ocean Institute's all about before she leads into our epic octopus odyssey of the day. So without further ado, Hannah, thank you so much for joining us and tell us all about it.
Thanks, Jesse. It's great to be here, and it's great to be connecting with Explore by the Seat of Your Pants again. It's been so long. Hi, everyone. My name is Hannah Nolan. I work for the Schmidt Ocean Institute. Schmidt Ocean Institute's mission is to boldly explore our unknown ocean. And the way that we do this is with our research vessel, Falkor 2, which we make freely available to the scientific community. And in exchange, we ask that they make their data publicly available for all. Today, we are joined by Drs. Gustavo Ramirez and Rachel Lauer, who are currently on expedition aboard research vessel Falkor 2 off the coast of Costa Rica. And they are looking for octopus gardens, which are nurseries where female octopus are brooding their eggs together. They're going to tell us all about this here soon. And but first they're going to take us on a tour of the vessel and tell us about the research. We'll have plenty of time for questions at the end. So with that, enough of me. I'm going to turn it over to Gus and Rachel. Hi, guys.
Hello, how's it going, everyone? Thanks for the nice introduction, Hannah. I am Gustavo Ramirez. I'm a professor of microbial ecology and computational biology at the California State University in Los Angeles. And we are indeed about 150 kilometers away from the Costa Rican port of Punta Arenas, right?
And my name is Rachel Lauer. I'm a professor at the University of Calgary in Alberta, Canada. And I am a hydrogeologist who studies how fluids move in and out of the ocean crust and support these communities of octopus and brooding octopus.
So once again, welcome to anybody watching. We are so excited to begin our tour of our amazing research vessel, Falkor 2. Again, if we can pan around a little bit, you can see right where we're at. We're in the aft deck of this gigantic research vessel. I believe I'm not sure of our specific specs, but I'm over 300 feet for sure, perhaps 350 feet. You see a lot of heavy equipment that usually sits here in the aft deck. And again, I just want to give you guys a sense of scale. We're literally sitting on what more or less could be a soccer pitch, right? Yeah. So it's a lot of space, not something that I'm used to in like the standard oceanographic research vessels that I work on. This ship is amazing. It's of course named the Falkor after the never-ending story. So we consider our very own luck dragon.
Yeah, I can say that this is definitely the most beautiful and potentially well-equipped ship I've ever been on. It's more sized like a drill ship. In fact, it's about 350 feet. We have a helipad on the ship that is not currently in use, but the aft deck here in terms of room for operations is unparalleled. In terms of other accoutrements on this ship, the food is incredible. We'll probably get a little tour of the galley. The working areas that are provided for the science is outstanding. And the crew, most importantly, makes this a completely different experience. We've had great success with just everyone we worked with on this ship. They clearly love science, and that's the most important thing for successful crews for science.
As Hannah has already alluded to, we are here to specifically find octopus's gardens. at the seafloor, and it's an incredibly cool behavior that was first recorded at this site approximately 10 years ago. Were you on the original cruise?
I was on both the original
Yeah,
cruises. Yeah, the first cruise was in 2013. In that one, we were actually using an remotely operated vehicle similar to Sebastian. This one was operated by Woods Hole called Jason. And we spent weeks, basically what we call mowing the lawn, going back and forth over this small seamount, Dorado, looking for places where water was coming out, and in the process encountered hundreds of octopus at the seafloor. And originally we were focused very much on heat flow and thinking about fluid flow and circulation patterns. And it was a unexpected discovery to find so many brooding octopus lining the cracks where the water was coming out with their eggs. And later in 2014, we went back using a manned submersible, the Alvin submersible. So two scientists and a pilot can fit into this submersible. And again, went to sample a bunch of these sites to gather those fluids and take lots of imagery of these octopus. That led to our collaboration with Dr. Janet Voigt, who is, I think, literally the world's expert on octopus, who is here with us and said, hey, this is crazy. These might be either a new species or an endemic species, meaning they're located specifically in one part of the world. So that's what we're here to do, is further explore whether or not that Dorado is the only place these octopus thrive. Are there other small outcrops that have been unexplored that resemble that habitat? And just in general, see what we see in terms of what's living on the seafloor.
And again, these first two, we can start walking. Yeah. These first two expeditions, approximately a decade ago, did reveal this unusual behavior. That video footage prompted a ton of hypotheses. Are the octopus happy here, right? So it's usually brooding mothers that tend to aggregate around this emanating relatively warm fluids at the cracks on the rocks on the seamounts. And it wasn't really known if their egg brooding was successful, because apparently 10 years ago it was really hard to see viable embryos. That is the first major breakthrough that we had in this cruise. During our first dive, approximately 10 days ago, we confirmed that there is indeed viable embryos in these amazing colonies of thousands of brooding mothers. The mothers basically embrace their egg clutches that can be 8 or 12 eggs at a time. And we saw very small eyes in those eggs staring back at us at first. And about 15 minutes later, we saw baby octopuses just swimming all around the remotely operated vehicles. That was fantastic. And that's the first major thing to report out of the work that's been done at this site during this expedition so far. Yeah. I guess I'll take a second. We are going to look at our ROV bay now, and then at some other oceanographic pieces of equipment. But I do want to highlight that thanks to the incredible vision of the Schmidt Ocean Institute, we're able to bring along two artists at sea. So this is Michael Drodge, who's working away. It's incredible how much time, how much effort is put into this art. And Michael's been right alongside all of us scientists, joining and helping me in my geochemical analysis of the sediment, working in the classification of brand new animal species that come out of every dive. And in their free time, Michael engages in doing art that's directly inspired by the science and the spirit of exploration that's so contagious across every one of the members of this expedition. Again, Michael's work is fascinating, abstract. It's a really cool, time-independent story of all the hardcore scientific exploration that's happening. We have a second artist on board too, Carlos Hiller, who we may encounter when we go into the main lab. But fantastic work, Mike. Thank you. So okay, let's go ahead and have a look at some of the major pieces of oceanographic equipment. Yeah, go ahead.
Yeah, just pan back to see the extent of the aft deck here, which if you've been on a research vessel before, this is incredible, the amount of space and
the soccer pitch.
Yeah, it's essentially a soccer pitch that we have to work on.
Yeah. Do you want to take ROV?
Yeah. Okay, so this is currently empty, but at about 5 p.m., we would have a recovery event where this device on the A-frame is actually going to recover and attach to the submersible, Sebastian, and bring it back to its cradle here to rest. And then this is a hub of activity for several hours afterward, where we're both collecting and processing our samples. The pilots and all of the engineers who work on Sebastian are doing maintenance in between dives, and in planning for the next dive. So this is sort of a staging area where we set things up to be added to what we call the front porch of Sebastian, which is sort of a rack where we can align and prepare for deploying different technology at the seafloor, different experiments, different tools for gathering samples for our scientific research. And this is just sort of, this whole area is abuzz with activity from about 5 p.m. till about 10 p.m. when ideally pilots are going to get some sleep and scientists are wrapping up with our sampling and prep. And then over here, on this side, we have another bay door that opens up and folds, ginormous bay door. And you want to talk about the CTD?
Sure. So this is a pretty standard piece of oceanographic equipment. And the CTD can measure temperature, conductivity, many important physical oceanographic parameters that scientists care about. But most importantly, the CTD also has this rosette of, what are these, 5-liter or 10-liter?
I think they're 10,
yeah,
but I'm not sure.
Okay, yeah. So many liters worth of ocean water can be collected by each one of these basically cylinders that are open at both ends at the time of deployment. What we can do is that if we want to sample water from, say, 1,000 meters under the waves, we can do that by independently fire any one of these bottles at a time, and that can be done from the bridge. So again, if firing the bottle simply means that the top ends, this right here, that are normally open, close. So there's a very simple mechanical triggering mechanism that, again, we can trigger from the bridge or from the control room that can close one of these bottles. And that means that 5 or 10 liters of water of the specific depth that we're interested in sampling remains in the cylinder once the top and bottom are closed, and will remain for the rest of the dive till we collect this. And of course, what we tend to do is take this all the way down to the bottom, maybe a meter off of the seafloor, then collect a bunch of a ton of water by closing a couple of these bottles, and then work our way up, continuing collections, although as we ascend this back up to our ship's deck. So I guess I'll jump in here for a second and want to show you guys a low tech yet very fun piece of equipment that I work with. I should give you a little bit of my own background. I'm a microbial ecologist, so I do believe octopus are fantastic, but I think bacteria are equally fantastic, or slightly even more so, at least in my biased perspective, you know. So anyway, there's bacteria all over the ocean. A drop of seawater contains 10 million microbes in some instances. And what's more interesting to me is that when you get to the seafloor, a single cubic centimeter of sediment, right, can contain hundreds of millions of microbes, if not more. Anyway, so I'm very much interested in who these microbes are and how they cycle important things like carbon, nitrogen, phosphorus, things that are ultimately nutrients to in the broader ecological sense. So anyway, to study that, when Sebastian, and like, I'm not sure if the audience has had a chance to see a picture of Sebastian, and this is a gigantic, amazing submersible. I worked with many submersibles before in Japan, Scandinavia, and the United States, but this submersible is just gorgeous, and it has its own art lining it. You know, it looks like it has an octopus tattoo. So it's amazing. It's a really cool looking sub. Long story short, there's manipulating arms in the front of the sub that basically allow the sub to literally become our avatar at the seafloor, right? It's our eye, because it has a ton of cameras. It's our noses, because it can detect some chemical parameters, and it's also our hands, right? So it's got 2 arms that, thanks to the incredible dexterity of a highly trained team of pilots that work very closely with us, the scientists here in the control room, can do a number of manipulation and seafloor experiments. So anyway, every time we find a place that seems appropriate for sediment collections, meaning that there isn't that many rocks, I'm always in the control room suggesting that we take a sediment core sample. So there's 8 of these that are deployed in a single port side that is to the left of a moving vessel, a port side rack, and one of the ROV arms can grip the top of these push cores, again, cylinders that are sealed at the top, can grip one of these and just lower itself down and eventually stab the seafloor. When the seafloor is stabbed by one of these push cores, note that there's a vacuum that remains here, and that allows us to basically slurp up a chunk of the seafloor, maintaining the stratigraphy, the order in which the sediments were laid. And that is extremely informative for those of us that are interested in either paleoclimate or understanding what microbial activities are going on beyond the seafloor, underneath the seafloor. So again, I figured that, again, not very fancy. Anybody can go to their local Home Depot and get all the pieces to make one of these. But I'm just having the ROV go to the seafloor and collect this very, very special sample for us, extremely invaluable to some of the science that we're trying to do here.
Okay, so just another thing to mention about coring. This is a very small core. There are other ways to sample meters of the seafloor. And what this is, once it comes back, is at the bottom, this is like a time machine. So the sediments that are captured at the very top are very recent and tell us what little sediments and dead critters have settled on the seafloor. In this particular area, sediment is falling at a very low rate. So what do you think the bottom of this would be in terms of time? How many, 1,000 years ago?
It could be.
Yeah, so
over 1,000 years. I would say close to 30,000 years or so. Yeah.
Okay, so we're looking at 2 ice ages in terms of time that is collected in a single sediment core. And what that does, the little bugs that are settling out, so there's little microbes within the water column, single-celled organisms that are thriving for days to weeks, eventually die and settle to the seafloor. The deposition and identification of them, these are called forams, and can tell us something about the climate on Earth at the time that they settled to the seafloor.
Thousands of years ago.
Yeah, so we're looking at, potentially 2 ice ages worth of sediments in a single small core. And again, this is really important for, you use the word paleoclimate, that just means old climate. So ancient climate in terms of Earth's history, because from studying the old climate, we can actually understand more about the modern climate and where we are in terms of where we're headed.
Exactly, yeah. So microbial time capsules.
Yep.
Yeah, for sure. Okay, I guess we're gonna carry on with our tour of the ship now and bring you guys into our laboratory facilities. Again, we're extremely spoiled, plenty of lab space in this cruise, as you'll see in just a second.
All right, so as mentioned on this cruise, we are sampling not just sediments. Probably the primary focus is the biology and the octopus. And we've taken a number of samples that initially are processed in this room. They are taken to this area here to be photographed. These are the glamour shots where we actually take full specimen images before any processing or investigating internally. So these are the stations for the initial processing. We've set up a scale bar, of course, to understand the relative size of the animal and different components. And
this entire area is a flurry of activity, right? This is where the VIPs come up.
Yeah.
The octopuses that have made it on the ship, and octocorals
and
have to get photographed here.
Yeah.
Exactly. I'll give you guys a quick tour of the cold room. This door is a cold laboratory. If I can get the lights on. And one of my colleagues, Dr. Miguel Sedemo from the University of Porto in Portugal, is hard at work here, usually taking mud and taking water collected from the seafloor and running microbial experiments. I'm not intimately familiar with the details of his experiments, but I know that he's spiking heavy metals to a level that could potentially be toxic for the microbes. And his plan is to track their activities based on the extraction of something called RNA, which is basically a cousin of DNA, or the information of DNA on its way to becoming biology. So yeah, so this is the cold room.
And
what do
what's
we
the
have?
temperature in here?
Temperature here is exactly what the temperature in a refrigerator would be.
Yep.
So that is 5 degrees Celsius. So because of that, we're going to go ahead and step away now. I'm glad I'm not Miguel, who has to spend 8 to 10 hours a day in here sometimes.
Yeah.
Yeah. So he comes to work here in many, many layers. Yeah.
And then we step into plus 20 in Celsius.
Yeah. Plus 20. Yeah. So go to the main lab. Yeah. Mission control. Fantastic.
All right, so we're making a right here across the stairwell.
The action never ends on the Falcor. There is always a flurry of activity going on. The peak of activity now is going to be this, and I'll try to keep it a little low just because there's recordings going on here too.
We're excited. This is the biggest tour we've ever gotten, I think, ever.
Yeah, so what you see here is our ROV control room. It is the brains of the operation, right? With at least 12 giant monitors. Is that correct? And what you see here to the left is our chief scientists and scientists. Yeah, so we can have a look at the scientists, Beth Orcutt there. And what the people on the left do is basically lead the scientific activity that's going on in this room. The people to the right are usually engineers and pilots, actually manipulating the ROV arms and navigating our submersible, Sebastian, close to 3,000 meters or 12,000 feet below us now. So yeah, the skill that's exhibited by this pilot is absolutely mind-blowing. You may be able to see now, they have to get a sense of a three-dimensional space at the seafloor by constantly panning back and forth between 4 or 5 screens that show different shots of whatever activity they find themselves working on, and that requires an incredible amount of visual skill,
dexterity,
and dexterity on their hands.
Yeah,
too.
think the most expensive video game in the world is being played right now at the seafloor. So we have a series of cameras. This room is showing, I think, 6 or 7 different views from extremely high resolution cameras that are being manipulated by the 2 people in the center here. To the right is a marine technician, an engineer who is keeping track of the maps and watching all of the controls. And the 2 arms that we discussed, the manipulator arms that operate almost like a little claw. One of them right now is attempting to take a sample of some of the fluid that is emanating from this small hole in the ocean crust. So that's one of the things that we're looking for on this cruise. Yeah. Heading to the main lab? Or do we want to walk through this room? Yeah, let's go through. I love this room. Yeah.
Yes, let's go through the room.
So again, some more screens, another bank of screens over here. Just showing, again, some of those same angles. We can actually see the view we were just looking at over here, as well as the winch and all sorts of engineering views to make sure that everything's kosher at the seafloor, and some of the plots and maps that are used for the navigation. Are we heading to the main lab? Okay. Now, depending on the time of day, there are no people or lots of people. Right now, a lot of the people are in the control room watching what's happening at the seafloor.
Activity here is very spasmodic.
It is, yes. Yeah, so this is just showing some of the stations very specific to different types of samples that are coming up from the seafloor. Here, for samples that we take, actual rock samples, we have the tools for smashing those samples, breaking them apart so we can actually see the core of those samples, because anything that spends time on the seafloor is going to weather very quickly, so it gets a very weathered rind. We want to see what it was before, when it was initially formed. Over here, this is no joke, a rice cooker. We're using it for sterilization of some of the equipment and tools that are used in creating these sampling devices. This is something we have not deployed yet, but is one of my favorites as someone who studies fluids. What this is about 4 years worth of fluid samples that are controlled by something you probably learned recently in science, an osmotic pressure gradient. Maybe not. If you have salt water on one side of a filter and fresh water on the other side, you're actually going to create a pressure gradient across that filter that very slowly pulls a sample of fluid into this very narrow tubing. And there's so much of it that there's about 4 years worth of samples can be stored within one of these. We place these at the seafloor next to one of these vents, collect those samples over 4 years, and then when we get them back on the ship, we can cut them into little pieces that represent 1 day's worth of sample.
Okay.
All right.
Yeah.
Where should we do them? Over here?
Sure. Yeah.
Yeah, we can do it over in Beth's area. All right.
Is there any questions? Yeah, we're
ready for questions.
Lots of
you guys have
questions. Lots of questions. We've gone on this incredible tour with you. I don't think we've ever covered such a geographical distance through a facility or ship in our entire history. So thank you for that. And you can rest and sit in some comfy chairs when this is all done. We've got a bunch of live classes with us with kids already at the cameras. Fantastic. I'm coming to you all in a second. YouTubers, if you want to chime in the chat, we'd love to hear your questions as well. I'm going to start with Mr. Hancock's class, joining us in Georgetown. If you guys want to kick us off with a question, you're good.
Yeah. We got questions for sure. Some of the students were wondering about how the octopus are coexisting. Are there predators nearby? They seem to just be relaxing. Like there's no worries in the world down there.
Fantastic.
Well, or it could be an extremely stressful environment, right?
Yeah.
Yeah. So again, when the octopus were first documented about 10 years ago, there was speculation that the brooding females made of this gigantic colonies of thousands of egg clutches were probably stressed. And I think it's we have our octopus expert nearby. I might run over there and bring her over here in a second. But just to make a long story short, they were breathing very fast, right? So it was video-based evidence that that was the bulk of or driving the bulk of this hypothesis of stress for the animals. Do they have natural predators? I'm not sure.
Yeah. So one thing that happened on this cruise in the course of sampling that gave us an idea of what those predators might be was these octopus are protecting their eggs. They're end of life. Their actual brooding and egg laying happens in the last quarter of their life, and they spend that time not eating, just protecting those eggs. And after sampling an octopus on this cruise, those eggs were exposed, and within a minute, there were eels and shrimp coming in to sample those eggs.
Yeah.
So I would say that eggs are the most vulnerable part of this, and that is precisely why the octopus
Can't leave them.
Can't leave them. Yeah, we have not seen predators of the octopus themselves, however.
Right.
Yeah.
That's correct. So the eggs are definitely vulnerable, and that's why the mothers or the females are very much committed to this final embrace.
Yep.
That may take years, actually.
Years for those eggs to develop fully and be viable.
They hug their eggs and they cannot let go because, again, we have video of within minutes of our collection of a mother for a specimen, the eels were munching on octopus caviar.
Yes, exactly.
Cool. How about that? Thank you for that great question, guys. And what a kickoff to the Q&A. Laura and Julian, we're heading to BC for you. If you want to unmute your mic, you've been sharing them in the chat, but more fun to have you on camera. So do come join us. Hey. Unmute though. Hey.
So we were wondering how deep the Sebastian can go.
Oh, 4,500. So
Yep.
that's quite an impressive depth, actually. I believe that at 4,500 meters, we're able to explore close to 90% of the seafloor worldwide, perhaps 93%.
Yeah, the trench. Actually, we're at just over 3,000 currently, but the trench here. So the trench is where the Pacific plate is going under the Caribbean plate in a subduction zone, and that tends to be the deepest parts of the ocean. Our trench here is about 4,500 meters,
Wow.
and my first dive in Alvin was to that trench.
Oh,
so
wow.
we went to 4,500 meters, just under.
Okay.
But that is, at the limits of
Right.
where that sphere can sustain those pressures.
And I believe that the average depth of the ocean globally is 4,000 meters. So
Yep.
we're definitely graded to go beyond what's average depth-wise. If we want to look at extreme examples, it can get a lot deeper.
The
but
Marianas.
The Marianas, yeah, Challenger Deep. I had an expedition to the Puerto Rico Trench, the deepest place in the Atlantic in 2018. And that was closer to 10,000
Yep.
meters. So long story short, there's definitely places where the ocean can get deeper, but collectively, right, if we look at the surface area of those parts of the ocean at the planetary scale, it's very, very small. Less than 1% of our planet in terms of the seafloor is actually deeper than 4,500 meters. So
Yep.
we have a lot of access with Sebastian.
2 follow-ups on this. One is to say for our audience, just in case you didn't know, more people, I still think this is true, this could have changed by now, more people have been on the moon than have been to Challenger Deep, so the deep ocean is very, very little explored in the really dark depths. And I love that you got to say my first dive in Alvin. So just for context for our audience today, maybe a few thousand people have ever been in a submersible of any kind, and I'm not even sure we're at that yet. So it is still one of the rarest experiences you can have on planet Earth. It is my all-time dream, by the way. And for our audience today, as we continue to do some ocean exploration, hopefully you get the chance to go down on one in your future as well. Great question, guys. Mr. Shaddis class, Chalk River, YouTubers, please feel free to chime in. I will do another round with all our groups, but you guys are good to go. 6 7 8.
Where are you and how often do you come back to shore?
Ooh, great question. Great question.
When do we come back?
Is that the question? When do we come back to shore?
A bit of both. Where are you specifically, and how often do you come back to shore? Like, how long are you out in the water? When are you back? What's the deal?
So we boarded our research vessel here. What is it, on the 30th?
30th.
Yeah, 30th of last month. So we've been out here, almost exactly 2 weeks. And everything goes to plan. We're scheduled to return to our home port, that is Punta Arenas, Costa Rica, which is about 150 to 160 kilometers, right? East of us.
East of us.
Yeah.
Yep.
So we will return to port on the 21st, and I believe we will be cleared to take a water taxi. Basically go down a ladder on the side of the ship, enter a smaller embarkation that then takes us into the port on the 22nd.
Yeah,
So
we might be up to 200 kilometers offshore, but
Yeah.
between those numbers,
Yeah.
we cannot see land currently.
No,
Yeah,
Cool.
it's been a minute since we saw land.
yeah, it's been a bit.
Thank you, too. We're going to do another round. Mr. Hankar's class, you got to have all those papers in your hand, so I'm assuming there are many more to come. And he's back at the computer. There we go. Hey.
Yeah, we had a student interested in some extreme weather. How does the weather affect where you are right now? How does it affect the octopus down below?
Yeah, so this is the rainy season in Costa Rica. We had, but before we boarded the ship, there were, I think we had like 4 or 5 storms a day on land. We have been extremely lucky out here. We've had 2 rainy days that impacted a little bit of maybe the deck operations, but in terms of impacting what's happening at the seafloor at 3,000 meters depth, there's no effect. There's probably some churning in the near surface in the photic zone where light is still penetrating, but when you get to 3,000 meter depths, there's literally no influence on what's happening down there. A bit more challenging for those of the crew who are working on the decks,
Right.
Obviously, when it's raining. But again, we've been really lucky. Despite being the rainy season, we've had, I think, 2 days. Is that right?
That seems right. Yeah.
Yeah.
Very cool. By the way, I'm so glad we got that specific question about impacting on the bottom. It really is like a whole different world, like the way things get food, the way the ecosystem is, the surface world and the very dark depths are very, very different. And it's a great opportunity to sort of distance the two of them. So thank you, Mr. Hankar's class. And Laura Julian, back to you two. Unmute your mic and you're good to go. Hey.
Okay. What are the screens with the colorful spots in the control room? Like, are they heat sensors or are they for depth?
Did you catch
Yeah,
that?
that's a great question. Yeah, I think I heard most of it. What types of sensors are they watching in the control room? Is that correct?
Yeah, and so
So
specifically when you went in the control room, there were screens with like really big spots on them, really colorful spots. So yeah, there you go. Perfect. Thanks
yeah,
for our tech team. What are those?
yeah, yeah. So those are images of things that are happening in the water column above the seafloor, using sound and sort of pinging the water column to image any sorts of, in this case, we see migration of phytoplankton that are tied to time of day. So it's called the biggest migration on Earth that you can actually see in those images as they move up and down in the water column in response to day and night. The other sensors and numbers that were present are also really important for the work that we're doing here. The temperature sensor in particular is temperature is taken all over the place on the submersible itself, on Sebastian, but we also have a high precision temperature sensor that the arm can actually use to stick into these cracks where we see water coming out to take the temperature of those fluids and understand in some cases how deep they're coming from, if water is going in or coming out of some of these seamounts, as well as oxygen sensors. And the reason that's important, the original work that we did in 2013 and 2014, we were interested in sampling what we call pristine fluid. And the reason that's important is most of the fluid that's coming out of the Earth's crust is sampled at engineered boreholes, which are basically like wellheads at the seafloor. So that water is flowing through metal. And if you're interested in the microbes that are living in the crust, you might have some impact or negative impact on them through that type of sampling. We knew this water was coming out of Dorado, and one of the interesting finds is that the water that's coming out of Dorado has less oxygen than seawater. And the question is, in Gus's work, who is using that oxygen and how is it being used in the crust? So how are the microbes taking that oxygen out? Why? What are they using it for? Metabolism or energy or other things? And for the biology, it's important because there's less oxygen available for those eggs that are lining the cracks. And that was sort of a concern initially. When we didn't see any viable eggs, the question was, is it tied to the fact that there's lower oxygen? And are these eggs being brooded in an area that will not be successful for them? Turns out we found the baby octopus. They appear to be successful and viable eggs, but that oxygen measure is a good indication of how different those fluids are from background seawater.
Cool.
So I guess as a corollary to this, yeah, these are the repercussions, right? Ecological repercussions. This is how the immediate environment here is affected by the physics of the first layer of the Earth, right? The first layer of the lithosphere. Slight differences in the temperatures of the rock bring in dense water wherever it's cold in whatever seamount, and they have that water, or that water circulates through the first layer of the lithosphere, and it evolves because it's originally deep seawater that goes into the crust, but as it's on its journey, powered by physics, it changes thermically. So physical properties change. It changes chemically. It evolves different chemical profiles, and what's most important to me is that it also changes biologically. And again, this change culminates in that water, after having gone through its journey in the cracks of the Earth, emanating wherever there is warmth, because it's less denser. So it's I guess a single physical equation for those of you that are into physics that can
They haven't had
dictate
physics yet.
what's happening. Oh, okay. So it's just warmth and cold that's driving this.
Cold water is
water.
denser.
Yeah.
And
yeah.
warm water is less dense.
Yeah. Okay. So yeah, that's driving this, and the repercussions or the results of that locally. So that affects how the beautiful octopuses that we're here to study behave, and their brooding behaviors at the scale of the planet. That's really important too, because that can change something called the oxidation reduction state of the planet, and how life evolves over many years in geological timescale. So just a couple of important points. It's important locally. What we're studying here is important locally, but it's also important at the entire scale of our planet for many different reasons.
I'll say to our students, if you can find anything in life that you are as passionate about as these two are about the science that they do, you're pretty set. It can be art, it can be history, it can be anything. But if you can go like a 5-minute thing without blinking of sheer excitement, that's a good sign. So thank you to you two for incredible passion today. I will note too, because deep sea stuff, we could go all day long, and I want to highlight for our kids just some great resources to keep learning going as well before we take our final question. One, the Schmidt Ocean Institute has their own YouTube stream. If you want to check that out, there's tons of resources to keep the learning going. I can't encourage that enough. For me, Blue Planet 2, the deep sea episode, is the best single hour of documentary filmmaking ever. So if you want to explore a lot of the things that our scientists have been talking about, that is awesome. And one thing that our students have really responded well to in the past, Natural World Facts, as a YouTube channel generally, does a lot of incredible stuff on the deep sea. So there's more to learn than we can possibly do in one 45-minute broadcast, but I love the dive in with all that. So thank you two very, very much. Again, I wish we could talk all day. I'm going to head to Mr. Shattuck's class for one final question, and then I'll make sure our classes have the resources to keep the learning going when we are done. So come on in and Chalk River.
What got you so interested in all this stuff?
That is a great question. Yeah, I think one of the things that gets me excited about, I mean, I come from a physics background and get to work with biologists, is these are spaces on our planet that we have not explored. We know more about the surface of Mars than we do about our own seafloor on our own planet. And understanding what is happening in the deep at these depths, whether it's biology, volcanoes, earthquakes, are really the holy grail for Earth science. And it's incredible to be a part of seeing things that nobody's put their eyes on before, and trying to understand these processes that really control life on Earth. Our ocean is what allows us to thrive as humans, and our understanding of it is still fairly limited. So it's like inner space. This is inner space, the deep ocean. We don't have to leave the planet to find the last frontier.
These microbes are indeed intraterrestrials.
Yeah.
And I guess what sparked my passion for science in general was a very specific event that I witnessed when I was 6 years old. So I was in southern Mexico at the time, and sometime in June, there was a full solar eclipse. I happened to be there for like 90% coverage of the sun. It just blew my mind. I was 6 years old at the time. I didn't know what to think about that. I was completely blown away that night suddenly came about and then dissipated within a 25-minute period. And anyone that seemed to know what happened that day with a credible explanation called themselves a scientist or an astronomer. So I became curious about what the scientific process was, right? Scientific thinking. And that sent me on this quest to understand what seemed like apparently supernatural phenomena and to think about those phenomena with the tools of modern science. And I've been on that quest ever since. 31 years later, I'm still here, inspired by that passion.
Yep. Thank you
Great
two
question.
so much for that. That is a great question, and that was a uniquely beautiful answer to it. So I appreciate both of you very, very much. Classes, I know we could go all day. I really appreciate your enthusiasm, and we're going to bring you in a minute to say a big thank you and farewell, as we always do. But I will note, if you want to follow along with Schmidt Ocean, they do amazing social media work, and they're at schmidtocean.org. And specifically for the Octopus Odyssey cruise, if you want to follow along with the science team and learn more about the great work they're doing, check out the link below. I'll make sure all of you have that in the chat as well. And for you too, and for Hannah, I'll bring you back in for this as well. What we do to end every broadcast, I'm going to bring in Mr. Hancock's class, Mr. Shattuck, and Laura and Julian to say a big thank you and farewell. You are all in the stream. Thank you so much, everybody.